Welcome to my YouTube channel Kinetics, and today we will see what is the concept of first order reaction, zeroth order reactions and second order reaction. Okay. So what is the general equation and how we will define that. Okay. So in the kinetics, okay. So what is the concept of zeroth order reaction? Okay, first order reaction. And second order reaction. Okay, so these are the three standard and important reactions: zeroth order, first order and second order reaction. Okay, so we will see them one by one. Okay, so how we will generally define this order of reaction and what is the equation of this? The equation is dCA by dt is equals to K into Ca to power n. Okay, dCA by dt is equal to K Ca to the power of n. Okay, Ca is here the concentration. At time t. Okay, so this is the equation dCA by dt is equal to K Ca to the power of n. Okay, so this is how we will define the equation of the reaction. Okay, so now we will see how we will define this zeroth order reaction. Okay, so zeroth order reaction. Okay, so we know that the equation is dCA by dt is equals to K Ca to the power of n. Okay, for the zeroth order reaction n is 0. Okay, and what was Ca? Ca was concentration with respect to time. Okay, so this was Ca, concentration with respect to time, and how we write Ca? Ca is equals to Ca naught into 1 minus Xa. Okay, so Xa is the conversion. So this is how we will write Ca. Ca is equals to Ca naught into 1 minus Xa. Okay, and in this zeroth order reaction, n value is equal to 0. So this term becomes equal to 1. Okay, so dCA by dt is equals to K. Okay, Ca to the power of 0. Okay, or it is independent of concentration. Okay, so dCA by dt is equal to K. Okay, so now we will integrate both sides for the zeroth order reaction. Ca is equals to Kt plus C. Okay, so the concentration is linear function of time. Okay, so if we plot the graph between Ca and time, this will be a linear. Okay, like this, concentration with respect to time. Okay, Ca is equals to Kt plus C. So we know that the Ca is equals to Ca naught into 1 minus Xa. Ca naught into 1 minus Xa is equals to Kt plus C. Okay, so 1 minus Xa is equals to Kt plus C by Ca naught. Okay, so 1 minus Kt plus C upon Ca naught is equals to naught, so Ca naught is equals to C. Okay, so Ca minus Ca naught upon K is equals to T. So we can also find what is the time and what is the C. C is equals to Ca naught and Ca minus Ca naught by K is equals to T. Okay, so if we know the time, we can easily tell also the conversion, which is XA. Okay, and this is how we will plot the graph, and this K plus C is equals to C naught. So this will be Ca naught because at time t is equals to 0, the concentration was Ca naught, initial concentration. Okay, so this is how we will do the mathematical manipulation with the equations of the zeroth order system. Okay, so zeroth order reaction. So in the zeroth order reaction, the half time or the time in which the concentration will be half or Xa will be equal to 0.5. Okay, so the half life of this zeroth order reaction, how we will find? We will put this Xa equals to 0.5. So 1 minus K into T plus Ca naught upon Ca naught is equal to 0.5. Okay, so this is how we will find the half life. Okay, so what is there in the half life of the zeroth order reaction? The time it will take from this converter from 0 to 0.5 or 0 to 50%. Okay, will be same as the time it will take from 50% to 100%. Okay, or it will be independent of concentration of the reactant. Okay, so if the concentration is Ca naught by 2, Ca is equals to Ca naught by 2, so it is independent of this the half life or the time it will take from the for the Ca from Ca naught by 2 to 0. So the next 50, this is 50%. Okay, this is 0%. Okay, initially it was Ca naught. Okay, this, so it was 100%. So this is half life is the time it will take from 100% to 50%, one half life, which is second half life, and these both times are equal in this zeroth order reaction. Okay, so this is the property for the zeroth order reaction, like that both the times are equal. Okay, so now we will move on to the first order reaction. Okay, so first order reaction. Okay, so we know that the Pca by dt is equal to K Ca to the power of n. Okay, as it is a first order reaction, so n value will be equal to 1. Okay, so as n value is equal to 1, Pca by dt is equal to K into Ca. Okay, so dCa upon Ca is equal to K into dt. Okay, so and if we integrate both sides, ln Ca is equal to Kt plus C. Okay, and we know that time t is equal to 0, this Ca is equal to Ca naught. So ln Ca naught is equal to C. Okay, or this equation becomes ln Ca minus ln Ca naught is equal to Kt. Okay, ln Ca upon Ca naught is equal to Kt. Okay, so this is the equation for the first order system, that ln Ca upon Ca naught is equal to K into T. Okay, so this is the equation for this first order system. ln Ca by Ca naught is equal to Kt. Okay, so as we know, or we can Ca is equal to Ca naught into 1 minus Xa. Okay, upon Ca naught is equal to Kt. So further we can solve like this also. So ln 1 minus Xa is equal to K into T. Okay, so like this also we can solve. Okay, so how to plot the graph of ln Ca by Ca naught is equal to K into T. So So like this we will plot. Okay. So Ca upon Ca naught, what it will become is equal to e to the power of Kt. Okay. So Ca is equal to Ca naught e to the power of Kt. Okay. So like this it will become. Okay. So like this. Ca versus time. Okay. So this is the equation will be Ca is equal to Ca naught e to the power of K into T. Okay, so this is the graph. How can plot this graph for this first order system? Okay, so now we will see what is the half life of this first order system. Okay, so now the equation which is there, this equation ln Ca by Ca naught is equal to Kt. We know that ln Ca upon Ca naught is equal to K into T. Okay, so half life will be Ca naught by 2 ln Ca naught by 2 upon Ca naught is equal to K into T. Okay, so ln 1 by 2 is equal to Kt. Okay, there will be minus. So ln 2 is equal to Kt. So the value of ln 2 is 0.693. Okay, so the half life will be 0.693 upon K will be equal to T. Okay, and this equation there it is minus K. Okay, so ln Ca by Ca naught is equal to minus Kt. So the equation is Ca is equal to Ca naught e to the power of minus Kt. Graph will be like this. Okay, at time t is equal to 0 it is Ca naught, and at time t is equal to infinite it is 0. So this is the time it will take for the concentration from reaching from Ca naught to Ca naught by 2.693 upon K. So this is how we will solve the equation for the first order system. Okay, for the first order system reaction. Okay.